Yes.
Okay. So we're done with this one, if I'm right. Um, Kani direta last sa inyong kopya diha diha ba ta last? Direta last kas no?
Oo, ma'am.
Proceed na ko. Okay. So for the topic today is the continuation of the JFET DC biasing. This is the last one for the type of biasing sa JFET, so voltage divider bias. So this arrangement that was applied to the BJT transistor amplifiers is also applicable to our FET amplifiers. The basic construction is exactly the same, but the DC analysis of each is quite different because IG is 0 ampere for field effect transistors. An additional resistor is used here, and the circuit is slightly modified from the self-biasing technique. A potential voltage divider using R1 and R2 provide the required DC biasing for the JFET. Now, for self-bias class, kanira man sila here, right? Now, for voltage divider bias, an additional resistor, si R1, and since na naman tayo diha, i-connect na to sa atong VDD. So R1 and R2 comprises the voltage divider. Okay. So for the formula of our voltage divider here, for the voltage divider rule, we have the same formula. Okay. Now remember for our BJT, okay, sa atong BJT class, it's VB, right? Or VB. Yes, it's VB, or it's also equal to our ETH, which is also equal to the voltage drop across our R2 resistor. And it has a formula for BJT of R2 VCC R1 plus R2. Now my question is, let's do a quick recap. A small recap lang. What's the counterpart for our collector? Collector for BJT, what terminal is it for our FET?
Drain, miss.
Yes, drain. How about for our base? Yes, base.
Gate, miss.
Gate. And for our emitter is the source. Okay. Now in here class, sa ato ang BJT, it's B here. For the counterpart of B, it's gate. So VG na siya diri. Okay. R2 is still the same. R1 and R2 is still the same. And the counterpart for our C is the drain. So that's VDD. So it's the same formula lang class. Lahi lang ang gipangalan sa iya ha. So that's R2 VDD divided by R1 plus R2. Now applying Kirchhoff's voltage law, KVL, in the clockwise direction to the indicated loop on the figure here, it yields VGS is equals to VG minus VS. And manipulating the formula, we can have VS, which is equal to the VG minus our VS. So substituting VS, which is equals to ISRS, and since IS is equals to ID, VS is equals to IDRS. It's the same. Now for our VGS here, na siya VS. Iyang gi-substitute si VS as IDRS here. So VGS has a formula of VG minus IDRS. This is just merely the VS. Okay, for the VDS, still the same formula for our self-bias and also for our VD. Now, for voltage divider bias, we have current IR1 and current which is denoted IR2. And in here, current for resistor 1 and resistor 2 is equal and it has a formula of V over R. Unsa man nga V ang niagi sa ilaha, VDD. Unsa man ang nga R, R1 and R2. Okay, here. So it's just that simple. So in order for us to be familiar on how to use the formula, same drill, determine the following for the voltage divider bias configuration. Okay, so we need to find VG first. Okay, so VG, formula ni VG is R2 VDD divided by R1 plus R2, right? And VG is R2, pili R2, R2. So R2 is 270,000 times 10 to the 3. VDD is 16. R1 is 2.1 times 10 to the 6 because that's capital letter M, mega, plus R2 which is 270K. So this would give 1.82 volts. Okay, so for letter B, we are tasked to find ID. And ID, okay, has a formula for IDSS, 1 minus VGS over VP square. And IDSS is given 8 milliamperes. 1 minus VGS is still not um present or wala paghihatag. VP is negative 4. So we need to find VGS. VGS, dali na lang, is equal to VG minus VS, which is also equal to VG minus ID RS, which is pilay VG, 1.82. ID, wala patay ID. Pila tong IS? We have 1,500 nga ohm for RS. And still, since we don't have ID, so ako ra na siyang gibutang diha. And substituting the equation for our VGS. So that's, oh, hold on. Sayop. IDSS is 8. So 8 times 10 to the negative 3. 1 minus pila ang atong VGS. VGS is 1.82. minus 1,500 ID all over -4. And don't forget to square it. Okay? Unsay mahitabo next? We need to simplify the given equation. Now, unsa pag-simplify? Focus first on the most complicated one or semi-complicated. This is negative, so positive. Okay? 1.82 minus 1,500 ID. Para di ta maglibog ni sign, mas dili labad tan-awon si positive kaysa ni negative. So, atong buhatag paagi kung mahimo. So, in here, we are able to make it positive because 1 minus the negative of this fraction is 1 plus the 1 plus the fraction. Okay? Next, what are we gonna need to do? LCD. Napa ba mo class? Kung nawa ang internet.
Napa,
Nara,
ma'am.
ma'am.
Okay. Thank you. Next, we need to do LCD. Okay? Unsa may least common denominator nila? 4. So, si 1 na siya invisible nga denominator nga 1. Every whole number has an invisible 1 nga denominator. So, 4 divided by 1. 4 divided by 1, 4 times 1, that's 4. Okay? Plus sign because it's plus here, 4 divided by 4, 1 times the term here. Dili na nimo sila mabulag. Okay? They are joined with negative or minus na sign. So, piano na nimo. Okay. Next. Pen. So 4 plus 1.82, we can add them up because they don't have any variable. Dili parehas atong 1,500 nga na ID. So 4 plus 1.82, that's 5.82. Kopyahon ang nahabilin. Don't forget the denominator, square. Okay, next na itong buhaton, it's the same for the previous discussion. Okay, para mabilinan ta og square of binomial class which is kani 5.82 minus 1,500 ID square. Buhaton na to is si 4 square atong ikuyog ni 8 milliampere. Now remember class kung mag-square ka, okay, square nimo ang numerator, square nimo ang denominator. Now since considered man nga bulag sila, no? So si 4 pwede na to makuyog ni 8. So, square siya. Kaya mag-square man ka sa babaw, no? Mag-square ka sa babaw, mag-square man sa ka sa ubos. And copy the remaining. Don't forget the square. Okay. So, we have 8 milliampere divided by 16. So, that's 0.5. 0.5 milliampere. Okay. Next, we have a square of binomial here. And if we have this binomial, we need to expand it. A squared plus 2ab plus b squared. Okay, so that's 5 squared plus ato sang sundon ang naa sa formula o ang iyang standard nga expanded form 5 plus b. The b here is the negative 1,500 IT. So 2 times a, what's a? Here, sundon na to class. A is 5.82. B is negative 1,500 ID. Okay, this one here is our A, and this one here is our B. ID plus B squared. So negative 1,500 ID squared. Simplify. Okay, 5 squared, 5.82 squared. Sorry, class. So that's 33.87 plus, okay, plus 2 times 5.82, that's 11.64. I-times pag yun na to si negative 1,500, mahimo na siyang negative 17,460. Dili malimot ni ID. And plus negative 1,500 square, that's 2,250,000. 2,250,000 or in mega, so that's 2.25 times 10 to the 6 ID squared. Times 10 to the 6 is mega class or in million. So what are we gonna need to do? Okay. Sayop. Di na lang ako isulat. Imong i-distribute si 0.5 milli sa kada term. So 0.5 times this one. So that's 16.94 times 10 to the negative 3. Okay. Positive 0.5 milli times negative here. Okay. So, ma-minus na siya. So, we have 8.73 ID. Dito malimot ni ID. And lastly, oops. That's 1125. Dili malimot ni ID square. Okay. Now, next, we need to have this equation format. Right? But in here, dili pa siya 0. So, transpose ID to the other side of the equation. So, may mo na siyang minus 8.73 ID plus 1125 ID squared minus ID because ID here is positive. I-transpose ni mo. Mahimo na siyang negative. Next, simplifying more. Okay. 16. And we have here variable ID and ID. So negative 8.73 minus 1. So that's negative 9.73 ID, okay, plus 1125 ID squared. Okay, we already have this one. Baliktad lang siya. Okay, we have the C, which is this one. We have B, and we have the A. Okay, dili jud malimot sa sign ni B class, kuyog jud na siya. Okay, so you can use your calculator. So you can have X at 6.23 milliampere and another X which is 2.42. And as I've mentioned before, we should always pick the smallest one. Okay, so this X here is our ID. Since we have our ID, we can find our VGS. So, VGS here, if you remember our VGS, kani, that's 1.82 minus 1,500. What's our ID? 2.42 milli or times 10 to the negative 3. So this is negative 1.81 volts. Okay, so we already have our VGS. Now we need to find next our VD. Okay, so we are done with what I call this VGS class now. So we need to find next our VD, VS, and VDS. So VD, what's the formula for our VD class? What's the formula for our VD?
VDT minus IDRD.
Okay, ID, RD, VDD. Atong VDD is 16. ID is 2.42 milliamperes times RD, which is 2.4 K or 2,400. So this would give 10.19 volts. Next, we need to find VS. VS has a formula of ISRS, but IS is equals to ID, so that's IDRS. ID at 2.42 milli. Okay. RS is at 1.5 or 1,500. So this would give us 3.63 volts. Okay, lastly, we need to find our VDS. VDS has a formula of VDD minus ID RD plus RS. So VDD 16 ID is 2.42 milli. RD is 2,400. RS is 1,500. So basically VDS is just 6.56 volts. Okay. Or in other way, we can find VDS by having VD minus VS. VD is 10.19 minus VS at 3.63. So this would still give us 6.56 volts. And that's how you solve the voltage divider bias example number 1. Do you have a question for that one? Okay, silence means yes. Yes. Silence means no sa karon nga panahon. So, using the transistor parameter of voltage divider bias, IDSS is 10 milliamperes and VP is negative 3.5 volts. Determine the following. VG, the same process ganina kas. Okay? VG. Formula ni VG, R2 VDD, R1 plus R2. So, R2 is 110 times 10 to the 3. That's kilo times VDD at 20. And R1 is 910,000 plus R2 at 110,000. So, VG is 2.16. ID. IDSS 1 minus VGS VP squared. And we have IDSS 10 times 10 to negative 3. That's milli. Okay. 1 minus VGS. We don't have VGS yet. VP is negative 3.5 squared. So ID. Oh, sorry. But VGS is VG is 2.16. We don't have ID. RS is 1,100. ID. So substituting VGS. So 1 minus VGS is 2.16 minus 1,100 ID negative 3.5 squared. Okay. So ID is 10 times 10 to negative 3. Susunod ba ito class? Hello.
Kuha ko ng LCD, miss.
Yes, that's true, but that's
Imo
for
ang
later.
positive, miss.
Okay. So 1 plus 2.60 minus 1,100 ID divided by 3.4 squared. And yes, we need to find the LCD. So what's the LCD? 3.5. Okay, 3.5 non invisible 1. So that's 3.5 plus 3.5 divided by 3.5. That's 1 times this term here. 2.16 minus 1,100. Kopyahan na dyan na ninyo. Square. Okay. Add any constant. So in this situation, we have here 3.5 plus 2.16. So that's 5.66. 1,100 ID squared. Okay. 5. 3.5 squared. 5.66 minus 1,100 ID. So we have square of binomial already. So 10 milli divided by 3.5 squared. So that's 0.81 or 82 ata. 82. 82 times 10 to the negative 3. Okay. And we need to expand that square of binomial. So 5.66 squared. Okay. Plus 2 times 5.66 negative 1,000 ID plus negative 1,100 ID. Bagyo, miss. So 5.66 squared. Lord. 32.04. Oops, that's not plus, that's minus. Okay. So 2 times 5.66, 11.32 times negative 1,100. So 12,452 ID plus 1,100 squared. So that's 1.21 mega. Oh, Pacific Ocean man is or no? My God. Dito ba kung lagi na? Ma'am Tess, araan. Hello? Can you hear me now?
Yes, ma'am.
Okay. So, sorry. Nagtabi mo gud ni diri og bagyo. And let's proceed. Okay, so negative 1,100 ID. Square na to, so that's 1.21 mega. So that's times 10 to the 6 ID squared. Okay, next we need to distribute the IDSS, which is 0.82. IDSS nga na ay 3.5 squared. Okay, so 0.82 times 10 to the negative 3 times 32.04. So that's 26.27 times 10 to the negative 3 times negative 12,452. That's negative 10.21 ID plus 992. Do we have the same answer as ID squared? Okay, we need to transpose ID to the other side of the equation. ID squared minus ID. So, simplifying that one, mayroon na siyang negative 10.21 minus 1. So, that's negative 11.21. 11.21 ID plus 992.2 ID squared. Okay, so finding our X. This one here is our A. This is for our B. This is for our C. Bali. Sorry. This is C, this is B, this is A. Okay. So X is just equal to calculator mode 53 negative 11.21 26.27. So we have 7.98 milli, and the other one is 3.32 times the negative 3 or milli. Manage class. And we need to pick the smaller value sa X, which is our ID. So, VGS, namon niya to ang VGS nga equation. 2.16 minus 1,100. ID is 3.32 times 10 to the negative 3. So that's 1.79. So negative 1.49 volts. Okay. So we already have our VGS. Next, we need to find our VD. Okay. So letter D, we have VD, which is VDD minus IDRD. VDD is 20. Oops. ID is 3.32 milli. RD is 2,200. So 20 minus 3.32 times 10 to the negative 3, 2,200. So this is 12.70. And E is VS. So that's IDRS. ID is 3.32 times 10 to the negative 3. RS is 1,100. So that's 3.65. Okay, and last is VDS, VDD minus ID, RD plus RS. VDD is 20, ID is 3.32 times 10 to the negative 3, RD is 2,200, RS is 1,100. So this would be 9.04. Okay, so VD is, saan naman eh? 12.70. VS is 3.65. So VDS is 9.04. Okay. Do you have any question, class? Hello? Are you still there?
Yes,
Wala na,
ma'am.
ma'am.
My question?
Wala na,
Wala
ma'am.
na, ma'am.
Okay, if we don't have question, then we can proceed to the third example. For the network below with VD is equals to 12 volts, we need to determine ID, VS, VDS, VG, VGS, and VT. Now to find ID, now remember class, VD is given. So we need to take consideration sa atong VD. Now remember, atong VD has a formula, VDD minus IDRD, right? Given si VD, which is 12, given si VDD, which is 18, given si RD, which is 2,000. So we can find our RD. So that's just IDRD, VDD minus VD, divide both sides by RD para makabilin si ID. So that's just VDD minus VD, RD. VDD is 18, VD is 12, RD is 2000. Okay, so 18 minus 12, that's 6 divided by 2000, so that's 3 milliampere. Okay, so that's our ID. No need to use the Shockley's equation because we can find ID because VD is given. So next, we need to find VS. ID is RS is 0.68. So 2.04. Letter C, we need to find VDS. Okay, VDS, VDD minus ID, RD plus RS. So VDD is 18, ID is 3 milli, RD is 2000, RS is 0.68K, or that's 680 ohms. So VDS is 9.96 volts. And letter D, we need to find VG. VG has a formula R2, VDD, R1 plus R2. R2 is 680. Okay. Class voltage divider ana siya class ha, gipahigda lang ni siya. It's the same ani. Ang kani din nga resistor gipahigda lang na siya. Kopya. Okay. Now for the VG class, duha ato ang for this voltage divider, duha ato ang bias. Now this voltage here is the voltage that flows from our drain to source. However, this voltage only flows for our gate terminal. So ang imong gamiton nga volta here is 12. R1 is 6. Hold on, this is not R2 is 110, and this one here is 680 plus 110. So this one is 1.67 volts. Okay, nakasunod ra mo class. Are you still there?
Yes, ma'am.
Okay, for VGS, we can do VG minus VS. Okay, VG is 1.67 minus VS, which is 2.04. This would give us 6 minus 0.6. So negative 0. Sakto ba? 37? Okay, we have our
37, ma'am.
VG. 0.37, okay. So VP. Okay, so from our Shockley's equation, ID equals IDSS 1 minus VGS over VP square. We can have this formula. VP is equals to VGS all over 1 minus the square root of our ID over IDSS. So VP is VGS, negative 0.37. 1 minus the square root of our ID, which is 3 milli, divided by the IDSS, which is 8 milliampere. So this would give us negative 0.95 volts. Okay, we have already solved the third example for our voltage divider bias. Do you have any question before I proceed to MOSFET? Class, hello?
Yes, ma'am.
Okay. Next, we'll proceed with MOSFET. MOSFET is metal oxide semiconductor FET. M for metal, O for oxide, S for semiconductor, and the field effect transistor. So in here, metal oxide semiconductor transistor, MOSFET, one of field effect transistor. Okay, it is another category of field effect transistor. The key difference between JFET and MOSFET is that the gate terminal in a MOSFET is insulated from the channel, which I will be elaborating later. Because of the insulated gate, the input impedance of a MOSFET is many times higher than that of a JFET. And we have two types of MOSFET, the D MOSFET and the E MOSFET. The D MOSFET class is also called the DE MOSFET. Okay, DE MOSFET. Anong gitawag siya DE MOSFET? Because this type of MOSFET can operate both depletion and enhancement mode. Now in here, I've mentioned that the key difference is that MOSFET has a gate terminal that is being insulated from the channel. Now looking at here, let's go back to the very first. Okay, can you see? So for our JFET class, kabantay mo, walay gap sa ato ang gate terminal, right? O kaning channel here, right? But for our MOSFET depletion mode and for the enhancement mode, nana siya'y gap here. Nana siya'y gap class. Okay, it's the same for our enhancement mode. Nana siya'y somewhat gap diha. That means that gi-insulate ang atong gate terminal from our channel that has our drain and the source terminal. Kopya. Okay, now to proceed, oops, kalula. Hello, can you hear me now?
Yes, ma'am.
Okay. Sorry, nangita ko charger. Kalabatan akong laptop. Okay. So next. So in here, okay, I already explained to you nga nung nanay gap ang atong MOSFET compared sa atong JFET. So we will proceed. Okay, so the basic construction of an N-channel depletion type MOSFET is provided in the figure. Okay, so a slab of P-type material here is formed from a silicon base and is referred to as the substrate. Okay, and it is the foundation on which device is constructed. This picture here, class, is an N-channel depletion type MOSFET. Okay, not like for our JFET. Okay, di ba atong JFET, pagpangan sa atong JFET is like this. If we have a JFET device here, okay, we take a narrow slab of N-type material, okay, this is N here, and diffused by P-type material, gipanganlan nato ang siya og N-channel, right? It depends on the narrow slab that we take nga gidiffusan og another type of material. For the PN or the P channel, okay, this is N, this is N, and this narrow slab of P-type material diffused with N-type materials, muna siya gitawag nga P channel. Now, for our MOSFET, okay, for our MOSFET class, dili ana ang iyang construction. For the MOSFET, it depends on what type of material nga imong diffuse or imong gibutang sa tuang MOSFET. In here, we have a P-type material, a slab of P-type material. Imo siyang gibutangan og N-type material. An N-type material is diffused to our P material, or which is the substrate. And in here, class, this one here is the channel, N channel. Okay, these two regions here is the drain, and this one here is the source. And the channel connecting them is the N channel. Okay, now in some cases, the substrate is internally connected to the source terminal. Okay, now in here, class, nay uban. Okay, ako sabsahan. However, many discrete devices provide an additional labeled SS or substrate supported, resulting in a four-terminal device such that in the figure. Ang uban class, ang kani siya diri, okay, ang kani nga substrate is internally connected siya to our source nga terminal. But some devices na siya ibutang diri nga fourth terminal, which is the substrate, which is also connected ra sa atong source and then connected sa ato ang ground, which makita na ninyo later. Depende na siya sa availability on what type of device that you are using. Okay, but kasagarang gigamit karon class is um, the substrate nga gi-connect lang. Okay, muna siya kasagarang gigamit ron. So the source and the drain terminals are connected through a metallic contacts to the end-doped regions linked by an N channel. So we have here metal plates, the black one class on a representation sa to metal. This is also metal here. Okay, this part here is our metal. Okay, the gate is also connected to a metal. Okay, but remains insulated from the N channel by a very thin silicon dioxide or SiO2 layer. The silicon dioxide is a type of insulator referred to as dielectric, which sets up opposing electric fields within the dielectric when exposed to an externally applied field. The fact that The silicon dioxide layer is an insulating layer. That means there is no direct electrical connection between the gate terminal and the channel to our MOSFET. Okay, now I repeat, we have metal here. Our drain is connected to a metal, the same as with our source. Okay, also with our gate. But ang kalahian sa atong drain source and gate terminal is atong drain and the source, they are connected diretso sa ato ang what? N-dope regions. Okay, the same for our drain. Now for our gate, it is insulated. This diagonal nga stripe here, okay, you can see this one. This is the silicon dioxide. It is represented by the diagonal lines. Okay, this silicon dioxide. See, gate is, yes, connected siya to metal, but it is insulated from our N channel. Dili pa sa atong source nga connected siya diretso sa ato ang N-dope nga region. Kopya. Okay, so next, the drain and the source are diffused into the substrate material and then connected by a narrow channel adjacent to the insulated gate. Both N-channel and P-channel devices are shown in the figure. This is the N-channel and this is the P-channel. Okay, we will use the N-channel device to describe the basic operation. Just like for JFET, we used N-channel JFET. And for the P-channel operation, it's the same except that the voltage polarities are opposite for the N-channel. Okay, now it is known class nga N-channel or N-type. FETs are the most used type of FET. Okay, so we will use that type of channel device. So next, the MOSFET can be operated in either two modes, just like I told you earlier, the depletion mode or the enhancement mode, and is sometimes called depletion enhancement MOSFET or DE MOSFET. Now, since the gate is insulated from the channel, okay, since the gate is insulated from the channel, either a positive or a negative voltage can be applied. Okay, now since um nakabulag man ang atong gate terminal from our N channel class, pwede ta pwede ta maka-apply o positive potential and a negative potential or positive voltage or negative voltage. The N channel MOSFET operates in the depletion mode when a negative to source voltage is applied or VGS, negative VGS, and in the enhancement mode when a positive VGS is applied. Okay, for depletion mode, remember for our JFET, they are operated on negative VGS. Okay, for enhancement, that's positive gate to source voltage. Okay, and before I forgot, the MOSFET is is a normally on MOSFET. Okay, normally on siya class Y. Kay bisan pa o nag-apply wala kay what do you mean? Uh, Nakagi-apply diha nga negative or positive nga potential naman gihapon na siya channel diha. If naatay channel, naikagian ang atong electrons and ID or drain current. So it's normally on MOSFET. Kopya? Normally on. Okay, next. So the reason for the label of metal oxide semiconductor FET is now fairly obvious. Okay, metal for the drain, source, and gate connection, oxide for the silicon diode connection, okay, or the insulating layer, and the semiconductor for the basic structure on which the N and P-type regions are diffused. The insulating layer between the gate and the channel has resulted in another name for the device, the insulated gate FET. or IGFET. Okay? Dali na siya masabot kay insulated man na ato ang gate from our channel. Although this label is used less and less in the literature, mas gigamit na si MOSFET. Why? Ngayon tag insulated gate. Yes. Okay. Kasabot ra ta insulated gate. And then what's the construction for that? Mas dali kasabtan si MOSFET. Kaya nga no, remember MOSFET, metal. This part here, the black one, metal for the drain, gate, and source connection. Okay. Oxide for the insulating layer because this is silicon dioxide. Okay. And next is the semiconductor, which what diha nagagikan which type of material wherein atong doped regions must be diffused or doped with. Okay? Metal, oxide, semiconductor, field effect, transistor. Diba? Mas daghan kag information makuha from MOSFET compared to IGFET. Ang nabao na mo sa IGFET, yes, insulated si gate from our channel mo ra. Okay? Do you get my point? Class? Hello? Can you still hear me?
Yes, ma'am.
Yes, ma'am.
Okay, now for the N channel class, we have here the symbols. This part here is the N channel and this part here is the P channel. Now for this part class, remember na ako giingon nga some devices kay naa siya supported nga substrate or substrate supported nga terminal. This one here. Na mga devices, inana still karon. And right here is the one that is connected to our source. Okay, this part here. But they're the same N channel. And for the arrow, that's pointing inward, so that's N channel. And for the P channel, that's pointing outward, so palabas. So pagawas ang ihang arrow. Okay? And the gap here, that means our gate terminal is insulated from our N channel or P channel. Okay. Next, we'll proceed to the basic operation and characteristic. Okay, so the gate to source voltage is set to be 0 volts here, just connected directly to our ground by the direct connection from one terminal to another. Okay, and a voltage VDD here, okay, is applied across the drain to source. Okay, this part here is drain, this part here is source terminals. The result is the attraction of free electrons on of the N channel for the positive voltage at the drain. Remember class, our electrons flows from source to what? Source to drain. And our drain current flows from drain to source. So since positive man ni siya nga potential diri and ang kani siyang negative potential diri nagduot maayo sa ato ang electrons. Okay, this is N channel. So we have the majority carries as electrons. The negative potential here pushes or repels the electrons present in our N channel. Gipush niya maayo and the electrons that kanang gipush maayo ni source potential from our source i-attract po na sa positive potential na gi-apply nato sa atong drain terminal. So basically our atong electrons flows from our source to our drain. Okay, and our drain current flows from drain to source. Okay, now the result is a current similar to our JFET as I explained na dyan ako bagula. In fact, the resulting current with VGS is 0 is labeled to us the IDSS. Remember, akong gibalik-balik before, what happens when our VGS is equal to 0 volts? Hello.
ID equals IDSS.
Okay, ID equals IDSS. That's right. It is also applicable here for our depletion mode MOSFET. Okay, next. When VGS is negative, the MOSFET is operating in the depletion mode, just like our JFET. When VGS is made more negative, okay, just like here, -1, -2, -3, and so on and so forth, ID decreases accordingly. This result is similar to JFET for the depletion mode. Okay, now for um, VGS at enhancement mode, it should be in positive. When VGS is positive, the DMOSFET is operating in the enhancement mode. This is the enhancement mode here. When our VGS is at 0, this is the depletion mode. And when VGS is at positive potential, this is at enhancement mode. Okay, VGS at 1. So we have here, for example, an ID value of 10.9 milliampere. Okay, so kung mataas ato, kung ma-positive atong VGS class, mataas po na atong kurente. Okay, like the JFET, the DMOSFET curves display an ohmic region, okay, current source region or the saturation region or the active region or the amplified region, okay, and a breakdown region, okay, here. If our VDS is greater than our VDS max or greater than our breakdown voltage. Okay, next here, do you have question for our D MOSFET?
None so far, ma'am.
Okay, so for E MOSFET, okay, we have here a slab of P-type material is formed from a silicon base and is referred to as the substrate. It's the same for our D MOSFET kung P-type, natay gidope nga N-type. And that's how you call N-channel. Depende sa unsay gidope nimo nga type of material. So the source and the drain terminals are again connected, okay, are again connected to a metallic layer or contact to the end-doped regions. Drain and source are connected to a metal and then connected through the end-doped regions. But note the absence of the channel between them. Okay, now for our D MOSFET class, remember natin channel here. Okay, natin channel there for our D MOSFET. Now in here, for E MOSFET, it does not have any channel. Okay, this is the primary difference between the construction of depletion type and enhancement type MOSFETs. The absence of channel as a constructed component of the device. Pareha rin siya to sila tanan kas except for the channel here, the N channel. So the silicon dioxide layer is still present gapon, and that layer insulated our gate from our P-type substrate. Okay, the silicon dioxide layer is still present to isolate the gate metallic platform from the region between the drain and the source. But now it is simply separated from a section of a P-type material. The P-type substrate now extends all the way to the silicon dioxide. Dili pareha sa atong D MOSFET nga diri ra to kutob dapit ang atong P-type substrate because we have an existing channel. For our E-MOSFET class, it does not have any channel, so therefore, P-type substrate extends all the way through our silicon dioxide nga portion here, okay, or side. There is no longer an N channel between the source and the drain. In summary, the construction of an enhancement type MOSFET is quite similar to that of the depletion type MOSFET, except for the absence of a channel between the drain and the source terminals. Okay, this one here. Muna siya na siya kalahian class. The MOSFET there is an existing channel that connects our drain to source terminal. For e-MOSFET, ang kalahian lang dyan is it does not have any channel. Okay? So for the n-doped region, standalone na siya. Walay normally connect nilang duwa. Now for the basic operation, okay, when the gate voltage is 0, okay, so we have a bias here for VDS, we have bias here for VGS. But if our gate voltage is 0 or VGS is 0, the current between the source and the drain is 0. Okay? So 0 paghihapon na siya class. For this reason, an e-MOSFET is normally off when the gate voltage is 0. Okay? That's why e-MOSFET class is also called normally off MOSFET. Okay? When gate voltage is 0, the only way to get current is with a positive gate voltage. Why? Kaya ako explain. In the figure, both VDS and VGS have been set at some positive voltage greater than 0 volts. Okay? Establishing the drain and the gate at a positive potential with respect to source. Here, grounded si source. The positive potential at the gate, ako na basahon class ako i-explain later. The positive potential at the gate will pressure the holes since like charges repel or same charges repel. Okay, and the P substrate along the edge of the silicon dioxide layer to leave the area and enter deeper regions of the P substrate. The result is a depletion region near the silicon dioxide. However, the electrons in the P substrate, which are the minority carriers of the material, will be attracted to the positive gate and accumulate in the region near the surface of our silicon dioxide layer. Okay, let me explain. Here, we have here a picture that can help me explain to you. Di ba class, wala pa man ni siya channel here, right? Wala pa na siya channel diha for e-MOSFET. Now, if we apply a positive potential for our VDS, which is the standard, and if we apply right now a positive potential for our VGS, positive potential means any positive number, any number above 0. Okay? If we increase if we apply positive potential to our VGS, di ba positive ni siya class? And our type of material here is P-type material, which the majority carriers are, kung majority carriers for our P-type material. What? Kung majority carriers. Hello. Kung majority carriers sa P-type material class. Class, are you still there?
Holes, ma'am.
Yes, holes, very good. So, since positive type material has majority carriers of holes, and this potential is positive, so positive, positive, okay? The law of attraction and repulsion, okay? So the same polarity repels. So since positive man nga potential and majority of our carriers here are holes, so si positive potential iyang iduot maayo si holes. Di ba na wala man na siya. Okay, drawing ba? Okay, here. Di ba wala pa man ni channel, right? In here. Now, if we add a positive potential here, class, okay? Positive potential here sa atong VGS, okay? Positive means positive potential here. Atong P substrate here has majority carriers of positive pod. Positive sa siya diri. Right? Everywhere is positive majority. Nara na ginagmay nga mga minority nga electrons, right? Positive man siya diri, positive ni they repel. Okay? So ang kaning potential diri nga positive iyang i-push maayo ang mga holes from here to a deeper region to a deeper region sa ato ang p-type material. Okay? Iyang i-push na pag-ayo the more ka magpatako sa imong potential sa VGS, positive potential sa imong VGS, mas taas og force, okay? Mas taas og intensity ang atong positive potential to push any majority carriers which are holes, to push any holes towards the right side of our p-type kani p-type nga material. Okay, now what happens? Now remember, naamantay naatay minority carriers which are holes, right? Electrons, right? Naatay minority carriers sa atong p-type substrate which are electrons. Ang mga nahabilin nga electrons diri class, ang mga nahabilin nga electrons here will stay there. Now remember, naatay VDS rather. Naatay VDS diri nga um positive, right? Positive potential pud ni siya diri. Okay? Positive potential and this here are what? This here are the minority carriers nga electrons. Ang mahitabuan na class, when VGS pushes our majority carriers didto holes, okay? Ang N diri class, ang iyang electrons sa ato ang N-dope nga region, since positive man ni siya, ma-attract siya padung diri. Okay? Ang electrons, okay, ang electrons nga naa diri, ma-attract padung didto. Okay? Because this part here is positive potential. Ig-agi ni positive potential diha, ma-attract si minority electron samot na ang electrons nga naa diri. Okay? Ang electrons pod nga naa diri, ma-attract pod siya ni positive potential here. So that's why we have a existing channel already. Okay? Nanatay existing channel. Since nanatay existing channel, maka-flow na atong electrons and of course, maka-flow na ang ato ang drain current. Follow. Ka-follow ra mo ka sa akong gimin? Hello, class? Class, are you still there? Hello?
Yes,
Transmissions daw
ma'am,
miss.
ma'am.
Ha? Okay. So if you don't have any questions, so we will proceed to the next slide. Oh, sorry. So as VGS increases in magnitude, okay? Okay? So kung patasan maayo atong VGS here, okay? To a more positive potential, the concentration of electrons near the silicon dioxide layer increases. Why? Patasan nato atong potential diri mas mudak ko ayang attraction. Pareha na kung mas magkagwapo ang lalaki daghang ang babae mo duol. Right? Di
Relate
ba?
din mo.
Unsa dong?
Relate si din.
Ka-relate ka dong then. So inana ang analogy. Okay, magkagwapo ang usa ka lalaki mas daghang babae ang matron ana niya. It's the same for our VGS. Magkataas ang positive potential sa atong VGS, mas daghan ang magka-attract nga electrons niya. Magtapok na na siya dapit sa silicon dioxide layer which comprises our channel. Okay? So for that, so asa na ta? Until eventually the induced n-type region, kani n-type region, hold on. Okay, kani n-type nga channel here, okay, is also called the n-type inversion layer. Okay, it can support a measurable flow between the drain and the source. Now, since there is an existing channel already, makadaghan na agianan ng ato ang electrons and nanapayagyanan ng ato ang drain current, of course. So the minimum VGS that creates the n-type inversion layer is called the threshold voltage. It is denoted by VGS VA or VT. Okay? Ang minimum VGS or ang minimum value sa atong VGS class nga somewhat nakapa-start og N-channel diri. Okay? Na-check ng gamay nga N-channel ba? Klaro nga N-channel. Okay? That's the minimum value of our VGS. It is denoted or symbolized by VGS TH or VT. So, when VGS is less than VGS TH, the drain current is zero. So, sabotable na jud class. Ang kanang threshold value class mo na siya'y pinakagamay nga value wherein maka-turn on na ang ato makabuhat na siya og n-type inversion layer between our drain and the source. Just like our silicon diode before, right? Mo turn on ra atong silicon diode if ang atong potential nga musud sa iyaha is greater than or equal to 0.7 volts. If it's less than 0.7 volts, then our silicon diode is not conducting or it's not functioning. Ka-follow mo sa akong gimin? Class? Hello? Okay. So as VGS is increased beyond the threshold level or or when VGS is greater than our VGS-TH, kung mulapas na siya sa ato ang gihatag na threshold value class, then the n-type inversion layer connects the source to the drain and the drain current can flow. Then liha na kas kung mulapas na siya sa atong threshold, then na jud tay clear. Okay? Clear layer nga maka-connect sa ato ang drain to source para maka-flow na ang ato ang electrons and current, drain current. So, with zero gate voltage, a JFET is on, whereas an E-MOSFET is off. Okay? Therefore, the E-MOSFET is considered to be normally off device. Off siya class because there is no channel existing. Okay? Mag-need pa ta og positive potential that is equal or greater than our threshold VGS in order for a channel to exist. And if a channel already existed, then electrons and drain current can flow. Therefore, it can turn on our MOSFET, E-MOSFET. If we don't have enough VGS, then wala tay channel. Therefore, off ang ato ang E-MOSFET. Kakuha ra ba sa akong idea?
Yes, ma'am.
Okay. So we have here, okay, for levels of VGS greater than our VT or threshold voltage, the drain current is related to the applied gate to source voltage by the following nonlinear relationship. Now before, for our D MOSFET, we have the Shockley's equation, right? ID equals IDSS 1 minus VGS over VP squared. Now in here, for our E MOSFET, since it only um, operates for our enhancement type, okay? It's on the positive side. So we have your ID equals K times VGS minus the threshold voltage or the threshold VGS squared. And K has a formula of ID on, drain current on, divided by the VGS on minus the threshold voltage squared. Okay. So for the symbols, it's the same for our D MOSFET. Ang nakalahi lang class is it's broken. Okay? Broken siya. That means there is no existing channel yet. For our D MOSFET, straight raman na siya. Okay? Di na siya broken for our D MOSFET. For D MOSFET, dito siya broken because naa siya channel. It is normally on. MOSFET. For eMOSFET, it is broken because there is no existing channel. It's a normally off device. Okay? Don't mind this. Ako ra ni siyang kuan ako madelete. Okay. So we'll proceed to MOSFET biasing. There are three ways to bias MOSFETs. Zero bias, voltage divider bias, and the drain feedback bias or the feedback biasing. So we will start with the MOSFET biasing. We have two here, the zero bias and the voltage divider bias. Wala lang kanina ko tasa ang ipangita class. Okay? So we have at the right side of our slide, you can see a zero bias D MOSFET. It's just like the same for um fixed bias class, no, wala siya, what do you call this? Wala siya source nga resistor. Okay, so zero bias is a popular biasing technique that can be used only with depletion type MOSFETs. This form of bias is called zero bias because the potential difference across the gate source region is zero, or meaning VGS is 0 volts. Now, when VGS is equals to zero, the drain current is equals to our IDSS, or the drain to source current when gate shorted. Now, when our VGS drives the gate a positive potential, then the drain current ID increases. Okay? Because magkataas ang potential, positive potential for our VGS, it can have a more concentration sa atong silicon dioxide nga layer. Right? So, when VGS becomes negative, okay, just like for depletion mode, kung si VGS himo na tong mas negative, then the drain current ID decreases accordingly. This part here is for the depletion mode and this part here is for the enhancement mode. Now to calculate the DC voltage at the drain, we have VDS is equals to VDD minus IDSSRD. Miss nga nung IDSS. Remember, this is zero bias. When gate to source voltage is at 0 volts, remember ID is just equal to our IDSS. So parehara ni siya nga formula for zero bias. Okay? Dili mawala ka. Same na sila. Zero bias means VGS is zero. When VGS is zero, remember always that our ID is equals to the IDSS. It is the maximum allowable current that can pass through our transistor. So to solve, okay, we have here zero bias nga problem. Determine the drain to source voltage in the circuit with VGS up is equals to negative 8 volts and the IDSS is equals to 12 milliampere. Now VGS off class, remember VGS off is the value of our VGS that cuts off our channel. Hence, there is no flow for drain current, right? And when our VGS off is equal when VGS off is um equal to our VP, VP for N channel is negative, VP for P channel is positive. Okay, when our VGS off is equals to our VP, then that's the time our channel has been cut off. There is no drain current flowing. Okay, to solve for the drain to source voltage, VDS, is just VDD minus ID RD, right? And VDD is 18. ID here is just equal to our IDSS because we are on zero bias, zero voltage for VGS. So that's 12 times 10 to the negative 3. RD is 620. So this is 10.56 volts. Okay, kafalo la class. Kafalo ra? We will proceed with voltage divider bias. No need to explain voltage divider kaya kasi ginatagbalik-balik sa meaning sa atong voltage divider bias. Okay? So for N-channel depletion type MOSFET at VGS at positive 1 volts, determine ID and VG. For ID, how do we find ID class? For D MOSFET, how do we find ID class? Who can give me the formula for ID in D MOSFET?
Katuya pong Shakli, ma'am.
Yes, that's right. So ID is equals to IDSS because depletion mode for D MOSFET is just the same for our JFET. Okay, remember that. So VP squared. So IDSS is 6 milli. VGS is positive 1. Okay, VP is negative 3 squared. So ID is equal to 10.67 times 10 to the negative 3 ampere or 10.67 milli. Ano siya ID. Next, we need to find VG. VG for voltage divider bias is R2 VDD R1 plus R2. So R2 is 10 mega. VD is 18. R1 is 110 plus 10 mega. VG is 1.5 volts. Okay, so that's for our VG. Dali na na class because we already solved that type of process before. Okay, next. We'll proceed to the e-MOSFET biasing. Okay, for e-MOSFET class, we have two also, the drain feedback bias or the feedback biasing and the voltage divider. So for a popular biasing arrangement, for enhancement type MOSFETs, we have here um, drain feedback bias, and a direct connection now exists between the drain and the gate, resulting in, okay, we have here the biasing arrangement for our drain feedback class. We have RD, RG, okay, we have our MOSFET, E-MOSFET, and we have our source without any resistor. Now remember class, for our RG here, di ba IG is 0? Di ba IG is 0? Kung i-multiply ni mo RG, resistor sa gate, it's 0. Right? Voltage drop for our VG is 0. Voltage drop for our gate terminal is 0. So, mura ra walay gamit si RG. So, gi-short na siya. Okay? Gihimo na siyang wire diha. And this is the DC equivalent. Okay? So, si VD equal ra ni VG. Why? Kung si VDD here, okay, moagi ni RD na ID kuyog, that's VD. Okay? That's the voltage drop across our drain terminal. Si VD here, tanaw nimo naka-connect siya sa atong gate terminal. Igabot ni VG, wala man tay any resistor. Okay? Because RG is shorted naman siya because IG is 0. Wala siya gamit. So si VD, ang value ni VD diri mudagan ra og wire, wala ra siya hapiton, why voltage drop may tabo, kay walay any external resistor added. So ang VD nga value diri igabot ni gate terminal VG gihapon. That's why VD is equals to VG. Now for our VDS class, okay, ang voltage drop or the measured voltage across our drain to source, okay, is just equal to our VGS. So kung moagi si VDS diri, igabot diri VD, right? VD. Si VD equal ni VG. So VG na ni siya. Igagi ni VG o ni VS diri, equal gihapon siya sa ni Agi diri. Right? Because in just like for our fixed bias class, di ba pareha og formula si VD ug si VD ug si VDS. Because we don't have any source resistor. Okay? So si VD nga ni Agi diri, igabot niya VG na nga niya. Okay, VG terminal naman ni gate. Then junction between these two terminal VGS is just equal to our VDS. Okay? Not unless na siya source nga resistor here. So man siya VDS is just equal to our VGS. And for the VDS class, it has a formula VDD minus IDRD. It's the same for the fixed bias for our GFET. And since VDS is equals to VGS, it has the same formula VDD minus IDRD. Nakasabot ra ba sa buot na ko ipasabot? Class.
Yes, ma'am.
Okay. We have an example. Determine ID for the enhancement type MOSFET at VGS is equals to 6 volts. Okay. Now we have here three VGS. As you can see, we have VGS on, VGS TH, and the VGS. Okay. Now for the VGS TH class, that's the minimum value of our VGS nga need niya kat-katon para mo initially turn on or naay channel, gamay nga channel nga ma-exist sa ato ang e-MOSFET. Now, VGS on class, that's the VGS value wherein atong channel or there is full channel na siya. Clear na iyang channel. Okay, that's the VGS on. And on VGS class, that's the value wherein we will need to solve our ID. Okay? With respect na sa ato ang ID nga kuhaonon. Okay? To solve, okay? So we have ID is equals to K, right? VGS minus VGS TH squared. Okay, but we don't have K, but K is ID on, okay, all over, taas ni siya, VGS on minus VGS TH squared. So we have our ID on at 6 milli. And for our VGS on, we have 8. And VGS TH is 3. You need to square it. So K is 0.24 milliampere per square volts. Muna siya ang unit class ha, ampere. Ang unit for K is ampere per square volt. Okay, but in here it is milliman, so you write milli. If you don't want to write milli, that's 0.00024 ampere per square volts. Kopya. Kopya, wala ka kopya. So we already have our K, so we can find our ID. So K at 0.24 times 10 to the negative 3 ampere per square volts multiplied by our VGS here. We have given VGS at 6 minus VGS threshold, which is 3. Don't forget to square it. Okay. Okay. So we have 9 volts, right? 6 minus 3 is 3. Squared is 9. So you cancel V squared here. So ang mahabilin, ID is just 0.24 times 10 to the negative 3 times 9. So that's 2.16 milliamperes. Oops, milli na siya. So we have already solved our ID. Nakasabot ra ba? Okay. Wala ni tubag, so mo padayon ako. Okay, in here, we have a voltage divider bias. Okay. So VG, the same na jud nga formula class. VGS is just VG minus VS. Kani siya here. Kani kay VS ra na siya. That's voltage drop across our source nga resistor. So VGS is just equal kani because VS is IDRS. Okay, and VDS is the same formula for our D MOSFET and J MOSFET rather. Okay, the same formula ra gid class. We're additional. So voltage divider bias. Let's solve this one. Okay, we need to solve VG daw. So ang pag-solve si VG, R2 is 18 mega times 40 VDD. R1 is 22 mega plus R2 which is 18 mega. So this would be 18 volts. Next, we need to find ID. Okay, and finding ID for E MOSFET, that's K VGS minus VGS TH plus VGS TH and VT are the same, huh? Squared. But we still need to find K ID on VGS on minus VGS TH. So ID on is given as 3 milli and VGS on is 10 volts minus threshold VGS squared. So K is 3 times 10 to the negative 3 divided by 25. That's 0.12 milliampere per square volts. We have our K. So ID is 0.12 milliampere per square volts times our VGS, which is 12.5 minus VGS TH at 5. Yan siya, 12.5 minus 5. That's 7.5 squared, 56.25. Cancel si V. So ID is just 6.75 milliamperes. Right, we already have our ID. Lastly, we need to find our VDS. Okay, VDS has a formula VDD minus ID RD plus RS. VDD is 40 minus ID at 6.75 times 10 to the negative 3. RD is 3,000 plus 0.82K or 820 ohms. So VDS is 40 minus 6.75 times negative 30,000 plus 6,820. It's 14.22 volts. That's our VDS. Okay, nakasunod ra ba mo?
Yes, ma'am.
Okay. And that's the end of our discussion for today. And ang akong ipabuhat na lang ninyo later is the last activity. You know the drill. Okay, and an assignment. Okay? Di na nato na ko i-appeal last topic kay murag full of theory, but I want you to have basic idea lang or background. That's why I will be giving it to you as an assignment lang. Para natin at least one assignment for this semester. Okay? Hello.
Yes, ma'am.
Okay. I will be sending this a screenshot kala sa atong GC. Don't worry.
When finals na to, ma'am? Karong Friday, ay next week Friday, ma'am.
Wala ko next week Friday do. Sabado.
Sabado. So, dungan sa night, ma'am.
Yes. Nara ko ihatag ninyo
Ah,
Friday activity para
okay, ma'am.
additional grade. Okay? June 2 man ang next Friday.
Yes,
Next
ma'am.
Friday, right?
Thank you, ma'am.
Training ano. Sige. Do you
Thank
have
you,
any other
ma'am.
question?
Yang katong kuan, ma'am, katong final project, ma'am. Karon na jud. Next week Tuesday na jud.
Next week, di ba ni ana man ko nga
Saturday lang, miss.
Tuesday
di ba ni ana ko
or
Tuesday to Saturday, May 30 to June 3. Dili lang mo
so
ana.
Dili ra mig adlaw nga magpa-check mo.
Yes. Yes.
Okay, ma'am.
Thank you,
Wala.
miss.
Thank
Ablo
you,
ko maron
miss.
June Tuesday, ma'am.
Dili, mamili mo na nga day. Kaya
Okay,
depende
ma'am.
po
Okay,
sa
ma'am.
akong availability.
Thank you, ma'am.
Sige. Do you have any other question?
Yang coverage ako, ma'am, mura gapon, ma'am. Ay,
Yes.
wala itong kuwan, ma'am, differentiation.
Ha?
Ang kuwan ba?
Numerical?
Dili sa kaning kuwan ba? Katong sa mga
Different.
ano? Katong kuwan ra ba? Comparison ba? Nga na gapon.
Ah,
Ang sa kuwan, second test.
type of exam.
Ah, yes, ma'am.
Naglibo. Wala pa ko kabuhat. Maybe nala ko'y kuan nga. Gamay lang siguro nga. Test 1 nga. Si Panggi test 1. Multiple choice. And for the test 2, um, gamay ra nga comparison. Okay? For example, sa kalihian sa DMOSFET, EMOSFET, sa kalihian sa JFET o MOSFET, ano ba? Sa kalihian sa mga bisag unsa nga kalahian. Okay?
Okay, ma'am.
Okay. Now for the third type of our exam, di mo dyan naman ang problem solving. Class, as I've always told you, di ginan ako lahion og kuan picture. Mura gyapon na picture or pagkabutang lahi lang value. Okay?
Yes, ma'am.
Mm,
Okay, miss.
okay. Kindly turn on your camera, please, for a quick screenshot.